Shapeways has partnered with Valve Games to open their IP to designers who want to print assets from games like the one I'm looking at here from Dota 2. Completion time of this lesson is anywhere from 20 minutes to 2 hours, depending on the level of detail and scale that you want to work on. This tutorial is designed to help you assess 3D video game models and adjust aspects of them to make them successfully 3D printable. It may seem obvious to state, but things you can make in software cannot always be seamlessly translated into physical objects. Computer animations and video game assets don't have to take the laws of physics, gravity, and material texture and resolution into account. I'll show you standard workflow for preparing mesh files from video games as 3D printable designs. This tutorial will be your guide to quick file preparation. First step, use Blender to convert our asset to an OBJ. Download and convert your game asset. I've downloaded Bane from Dota 2. Valve encourages remixing, so they provide .fbx and Maya file types, but we'll use the .fbx to convert to a .obj so that we can take advantage of ZBrush sculpting and remeshing. Open Blender and choose Import. Use the rigging markers to repose if you desire, and then select and delete the rigging markers. Finally, choose Select All by Type, Mesh, and export as an OBJ. Use ZBrush to edit the mesh and make it printable. Import the converted .obj mesh as a subtool. Next, go to the Z plugin menu, 3D Print Hub, and click Update Size Ratios and select the smaller set of ratios displayed in millimeters. Knowing we are at the correct scale will allow us to identify problem areas in the design. When printing in nylon, the thinnest possible edge or unsupported wall anywhere in the design is 0.7 millimeters. Now we need to increase our mesh resolution to make the following improvements in the surface smooth. In geometry, set the Dynamesh resolution to 350 and click Dynamesh. Next, go to Z-Remesher, click Freeze Border, and click half under Target Polygon Count, and finally, click Z-Remesher. With this step completed, we can see that there are areas on the fingers, shoulders, and teeth that will need to be thickened, and that there are still low polygon striations on the surface of the model that we can smooth over. We'll do all this in the next step. I'm going to switch the material so that we can see the surface of our design better. Once thin areas are identified, we need to selectively thicken just those areas while avoiding poofing out the entire model and losing the sharpness of our overall geometry. We'll do this by alternating between a smoothing brush and an inflate brush. For definitions of what needs to be fixed, the best resource is the Shapeways Materials Information page. It will be important to adjust your brush size for smoothing so as to avoid creating non-manifold intersections in tight areas. This part of the process is potentially time-consuming. Keep scale in mind while editing fine detail, since some of the very fine details won't be visible on the print. To add detail back in, you can experiment with different brush settings. Once smoothing is satisfactory, Z-Remesh again to export with good manifold geometry. Then go to Z plugin and 3D Print Hub to adjust the export settings for model size. We're aiming to make this model about 10 centimeters tall, so go to the sliders below and set the longest axis, in this case the Z-axis, to around 100 millimeters. Ensuring accurate scale is the most important factor when preparing a file for 3D printing.